Welcome, everyone. I'm excited to kick off our presentation today with this first slide titled CIRCLES. Today, we'll explore the fascinating world of circles, covering their properties, applications, and some interesting facts. So, let's get started and enjoy the journey through this fundamental shape. Let's take a look at the conclusion of our presentation. We've covered several key topics, starting with the area of a sector, which helps us understand how much space a sector occupies within a circle. Then, we explored related terms of a circle, ensuring we have a solid grasp of the foundational concepts. We also discussed the area of a segment of a circle, which is particularly useful in more complex geometric problems. Moving on, we examined the area and circumference of a semicircle, linking the ideas of area and boundary length. We defined what a circle is and looked at some useful results to remember for quick calculations. The area of a circle is a fundamental concept, and understanding the area of a sector ties directly into that. We also discussed the perimeter of a circle, which is essentially its circumference. Finally, we started with an overview of the contents, setting the stage for the detailed discussion that followed. Altogether, these points form a comprehensive understanding of circle-related geometry, which is essential for solving many geometric problems accurately. In this part of the presentation, we're going to explore how to find the areas of different combinations of plane figures that involve circles or parts of circles. We'll look into concepts like the perimeter and area of a circle, which are fundamental in understanding circular shapes. Additionally, we'll discuss two special parts of a circular region called sectors and segments, and learn how to find their areas. Lastly, we'll go over some related terms about circles to help solidify our understanding. These topics are essential as they connect to the broader theme of understanding and calculating areas in geometry, especially when dealing with circles and their parts. So, let's dive into these concepts step by step to see how they all fit together. Let's take a closer look at some fundamental concepts related to circles. First, we'll examine a segment of a circle and understand how its area is determined. A segment is basically a part of the circle cut off by a chord, and calculating its area helps us see how different parts of the circle relate to each other. Moving on, we'll explore areas related to circles in general, including sectors, which are like slices of the circle. Understanding the area of a sector is crucial, because it connects angles and arc lengths to the area calculations. We'll also look at how areas combine when we consider different plane figures, such as overlapping shapes or composite figures. This helps us solve more complex problems by breaking them down into simpler parts. When it comes to the area of a circle itself, remember that it's given by the formula pi times the radius squared, which is fundamental in many geometric applications. Next, we'll discuss the perimeter of a circle, which is more commonly called the circumference. Knowing how to find the circumference is essential for understanding the boundary length of circle-related figures. Finally, we'll review key terms related to circles, like radius, diameter, and arc, that help us communicate and solve problems more effectively. Connecting all these points, you'll see how understanding circles deeply enhances your overall grasp of geometry and its applications. A circle is essentially the set of all points that are at a fixed distance from a specific point called the center. Imagine moving a point around in a plane so that its distance from this fixed point never changes. That's how we define a circle. Another way to look at it is to think of all the points in a plane that are exactly the same distance from a fixed point. Those points collectively form a circle. The key idea here is that the distance from the fixed point, which we call the radius, remains constant as the point moves around. This concept is fundamental because it helps us understand the shape and properties of circles, which are basic but very important in geometry and many real-world applications. So, in essence, a circle is the locus of a point moving in a plane with a constant distance from a fixed point. Here, in the figure, OP is the radius of the circle with center O. The line segment that joins the center O to any point on the circle is called a radius of the circle. So, essentially, the radius is the distance from the center to any point on the circumference. This is a fundamental concept because it helps us understand the size of the circle and is key to many other properties we'll explore later. Remember, no matter which point on the circle you choose, the radius remains the same length. This consistency is what makes the radius such an important term in circle geometry. Here, in the figure, we can see that a circle divides the plane on which it lies into three distinct parts. The first part is the exterior of the circle, which is everything outside the boundary. The second part is the circle itself, which is the boundary line. And the third part is the interior of the circle, which lies inside the boundary. So essentially, a circle acts like a divider, creating these three regions in the plane. Understanding this division is fundamental because it helps us grasp how circles influence the space around them, which is a key concept in geometry and the overall theme of our presentation. The chord which passes through the center of the circle is called a diameter of the circle. Now, a diameter is a special kind of chord because it actually passes through the very middle point of the circle, which we call the center. It's important to remember that a diameter is actually the longest possible chord in a circle. In the diagram, for example, or is the diameter of the circle because it goes straight through the center. Meanwhile, PR is another line segment connecting 2 points on the circle, but since it doesn't pass through the center, it's simply called a chord. So, whenever you take 2 points on a circle and connect them with a straight line, that line is called a chord of the circle. The key difference is that the diameter is a special type of chord that goes through the center and is the longest one you can draw. Understanding these concepts helps us see how different lines relate to the circle's structure and set the foundation for exploring their properties further. Here in the given figure, PQR is the major arc because it is the longer one, whereas PR is the minor arc of the circle. When P and Q are the ends of a diameter, both arcs become equal, and each is called a semicircle. The piece of the circle between 2 points is known as an arc of the circle. Remember, an arc essentially represents a segment of the circle's circumference, and understanding the difference between major and minor arcs helps us analyze various properties and angles related to circles. This concept ties into the overall theme of understanding circle geometry and how different parts of a circle relate to each other. In this slide, we can clearly see the major and minor segments of a circle. Now, what's interesting here is how these segments are formed. The region between a chord and either of its arcs is called a segment of the circle. Essentially, when you draw a chord, it creates 2 regions. One is the segment, which is this area between the chord and the arc it subtends, and the other part is the remaining area of the circle. Recognizing these segments helps us understand the geometric relationships within circles better. This concept is fundamental as we explore more advanced properties of circles and their segments throughout this presentation. Here in the given figure, you can see that the minor arc corresponds to the minor sector, and similarly, the major arc corresponds to the major sector. Now, the region between 2 radii, which join the center to the endpoints of the arc, is called a sector. Think of it as a slice of the circle, like a piece of pie. This concept is fundamental because it helps us understand how parts of a circle relate to angles and arcs. Recognizing the difference between minor and major sectors is crucial, as it lays the groundwork for more advanced topics in circle geometry. So, whenever we talk about a sector, remember it's essentially the area between 2 radii and an arc, and whether it's minor or major depends on the size of that arc. Let's now talk about the area of a circle. When we think about a circle's area, we're essentially looking at how much space is enclosed within its boundary. The key idea here is that the area depends on the radius of the circle, which is the distance from the center to any point on the edge. The formula for calculating this area is pi times the radius squared. Pi, of course, is approximately 3.14159, a constant that appears in many geometric formulas. So to find the area, you take the radius, multiply it by itself, and then multiply that result by pi. This formula is fundamental because it connects the radius directly to the amount of space the circle occupies. Understanding this concept helps us see how changing the radius affects the size of the circle, which ties back to our overall theme of understanding shapes and their properties. Let's talk about the area of a sector. When we refer to a sector in a circle, we're talking about a slice of the circle, kind of like a piece of pie. The area of that sector depends on how big the angle of the sector is, as well as the size of the circle itself. To calculate this, we use a simple formula that involves the area of the whole circle, which is pi times the radius squared, and then take a fraction of that based on the sector's angle. Specifically, the area of the sector equals the angle in degrees divided by 360, multiplied by the total area of the circle. This helps us find just the part of the circle we're interested in, which is especially useful in fields like engineering, architecture, and even in everyday problem solving. Remember, understanding how to find the area of a sector is a key step in mastering the properties of circles and their segments. Now, let's move on to the concept of the area of a sector. A sector, as you might remember, is like a slice of a circle, similar to a pizza slice. The key point here is that the area of this sector depends on how big the angle is at the center of the circle. The larger the angle, the bigger the sector. To find the area, we take the fraction of the circle that the sector represents, which is based on the central angle, and then multiply that by the total area of the circle. This helps us understand how much of the circle's area is contained within that sector. Remember, the formula involves the central angle in radians and the radius of the circle. This concept connects to our overall theme of understanding geometric measurements and how different parts of a circle relate to its total size. It's a fundamental idea that helps us analyze and calculate areas in more complex shapes and real-world applications. Now, let's move on to the area of a segment of a circle. This is a fascinating concept because it helps us find the size of a specific portion of the circle, which is bounded by a chord and the arc it creates. To understand this, we need to consider the circle's radius and the central angle that subtends that segment. The key idea here is that the area of a segment is a part of the circle's total area, and we can calculate it using a formula that involves the central angle in radians. Remember, the formula combines the area of the sector defined by that angle minus the area of the triangle formed by the radius lines and the chord. Grasping this concept is crucial because it connects to how we analyze parts of a circle, which is essential in many real-world applications, from engineering to design. So, understanding the area of a segment deepens our overall comprehension of circle geometry and its practical uses. Thank you. Now, as we wrap up, I want to emphasize the key points we've covered today. First, we've explored the main concepts thoroughly, making sure to highlight what truly matters. Throughout this presentation, I've aimed to connect each point back to our overall theme, showing how they all fit together. Our goal has been to provide a clear understanding of the topic and leave you with practical insights you can apply. I appreciate your attention and engagement, and I hope you found this session both informative and inspiring. Thank you once again.